Hello viewers, I am Kausalya. Today we are going to find the torque voltage electrical analogous circuit of the problem example 1.13 in control systems. So here I had already written the expressions which are governing the respective masses. Now we are going to draw the torque voltage analogous circuit. So here as the name mentions, here the torque will be represented as a voltage here, and regarding this J1 will be represented as L1 and J2 as L2 and J3 as L3. And here this B1 will be represented as R1 and B2 as R2, and this K1 is represented as 1 by C1 and K3 as 1 by C3, and omega 1 is represented as I1, omega 2 as I2 and omega 3 as I3. Those who are watching this video for the first time, kindly go and see the video where I had given the basic introduction about torque voltage and torque current electrical analogous circuits. Right. So the next one is, so this is the first expression, right? So the first expression consists of a torque T. So torque is nothing but voltage. So just draw a voltage source here. It is nothing but your E of T. And next one we are having J1. J1 is nothing but your L1. So just draw an L1 here. And the next one we are having B1, and B1 is common for loop 1 and 2. Similarly, K1 is common for loop 1 and 2. So this B1 is represented as R1. So just draw a R1 here. And again K1 is represented as C1, and this is K1 is also common for 1 and 2. So just draw a capacitor C1 here, and this is our first loop. Let I1 be the current which flows through your loop 1. Right. The first expression consists of 4 parts, 1, 2, 3, 4. Again our first loop consists of 4 elements, 1, 2, 3, 4. That's it. And next one is the second loop. We are having J2. J2 is represented as L2. So here just draw an L2. And again we are having a B2, and B2 is common for 2 and 3, loop 2 and loop 3. So this B2 is represented as R2. So here just draw an R2 here. And the next one is B1. This B1 is common for 2 and 1, which we have already drawn as R1. And again K1. This K1 is common for loop 2 and 1, which we have represented as C1 here. So that's all. Our second loop gets completed. Again this expression consists of 1, 2, 3, 4. 4 parts, and here our loop consists of 4 elements. Just count 1, 2, 3, 4. And let the current flowing through this loop 2 be I2. Right. And our third expression is, again here we are having J3. J3 should be represented as L3. So here just draw an inductor L3. And again B2. This B2 is represented as R2, and this R2 we had already drawn here. And again here I am having K3. This K3 should be represented as C3. So here just draw a capacitor C3. Again the third expression consists of 3 parts, 1, 2, 3. And again our loop also consists of 3 elements, 1, 2 and 3. Right. Let the current flowing through this loop 3 be I3. And next we are going to apply Kirchhoff's voltage law, and I am going to write the expression. So here for writing this expression, as we all know, here this is your source voltage E of T. So this E of T is nothing but this is equal to L1 into current flowing through this loop is I1. So here dI1 by dt plus voltage drop across the resistor is given by I into R, that is Ohm's law. So here the current flowing through this resistor is I1 and I2. As I am considering loop 1, I have to write it as I1 minus I2 into R1 plus again here I am having capacitor, so I have to write it as voltage drop across a capacitor as 1 by C1 integral of, again through this capacitor I am having currents I1 and I2. Okay, both are flowing through this capacitor. So here I have to write it as I1 minus I2 into dt. Right, this is expression for our loop 1. Next, consider loop 2. So while considering loop 2, there is no source voltage here. So I am writing it as 0. So which is equal to, I am having these 5 elements, right? So I am starting here from C1. So 1 by C1 integral of, as I am considering loop 2, I have to write it as I2 minus I1. So write accordingly, I2 minus I1 into dt plus again I2 minus I1 into R1 plus here L2, through this L2 only current I2 is flowing. So I am writing it as L2 into di2 by dt plus I am having here R2, through this R2 two currents are flowing, right, I2 and I3. So I have to write it as I2 minus I3 into R2. As I am considering loop 2, so the current I2 should be written first. So here I have written I2 minus I3. Now consider your loop 3. Again in this loop 3 there is no source voltage, so which is 0. So 0 equal to, here I am writing first I start with R2. Through this R2, I2 and I3 are flowing. So I have to write it as R2 into, as I am considering loop 3, the current I3 should be written first. So you have to write it as I3 minus I2 into dt plus L3 into, through this L3 only current I3 is flowing. So L3 into di3 by dt plus again through this capacitor only current I3 is flowing. So 1 by C3 into integral of I3 into dt. Right. So this is your respective torque voltage analogous circuit, and these are all the respective loop equations. So here just you can write it as applying Kirchhoff's voltage law. We are having these three expressions. Right. So from this, that's all. Here the force voltage analogous circuit is over. Now we are going to draw the, torque voltage analogous circuit is over. Now I am going to draw the torque current electrical analogous circuit. So to draw this torque current analogous circuit, again I am going to consider this same diagram. From this diagram, I will tell you a simple trick how to draw the torque current analogous circuit. Right. So the thing is, again I am going to redraw this diagram. So here I am having an voltage source E of t. So from this voltage source I am having an inductor, I am having a resistor, capacitor, and again I am having another inductor, and here I am having a resistor and another inductor and a capacitor. So here L1, L2, L3, R1, C1, R2, C3. So this is your I1, this is your I2, and this is your I3. Okay, this is the diagram which you had obtained from the torque voltage. So this is a torque voltage diagram. From this diagram, I am going to draw the torque current analogous circuit. So before that, there is some basic things here we have to modify. So here, regarding in your torque current analogous circuit, this torque is represented as current and the respective elements are represented as, that is J1, J2 and J3. These are represented as respectively C1, C2, C3, and next we are having the B1 and B2. So B1 and B2 is represented as 1 by R1 and 1 by R2, and again K1 is represented as 1 by L1 and K3 is represented as 1 by L3. And apart from this we are having omega 1, omega 2 and omega 3, and these are represented as V1, V2 and V3. So from this diagram, I'll show you how to draw this torque current analogous circuit. So this voltage source should be represented by a current source. So just write it as I of t. So from this I of t, as I already said, elements which are connected in series should be represented as elements in parallel. And here this inductor will be replaced by a capacitor and capacitor will be replaced by an inductor. That's it, right? So here this voltage source is replaced by a current source, and next one is this inductor in series should be represented as a capacitor in parallel. So this is your C1, right? And next one is here we are having common elements between loop 1 and loop 2. So these common elements should be represented as between node 1 and node 2. So here I am having R1. This R1 will be always represented as same R1 here. So next one is C1. C1 should be represented by an inductor. So just draw an inductor between your, let this be your node 1 and let this be your node 2. That is V1 and V2. So this is your R1 and this is your L1. Right. That's all. So to this first node, 4 elements are connected because in our first loop we are having 4 elements, 1, 2, 3, 4. And to this node 1 we are having 1, 2, 3, 4, 4 elements. Right, that's it. And next one is consider your loop 2. So in this loop 2 we had already drawn these 2 elements, right? So we have to draw the rest, L2 and R2. So here again this L2 should be represented by a C2. So this is your C2, and again this R2 is common for loop 2 and loop 3. So again this R2 is common for node 2 and node 3. So node 2, let this be your node 3 and this is your R2, right? And again here in this loop 3 R2, there is R2 is already drawn. So we have to draw L3 and C3. So again these 2 elements are in series. We have to represent these 2 elements in parallel. We have to draw inductor by a capacitor. That is, we have to replace inductor by a capacitor and capacitor by an inductor. So here in this case, this inductor, just replace it by a capacitor. This is nothing but your C3. And here this capacitor should be represented by an inductor, which is nothing but your L3. Just count the number of elements now. In loop 3 we are having 1, 2, 3. Okay. Again to this node 3, 1, 2, 3. Right. So everything is perfect. Now I am going to write the expressions for the respective torque current analogous circuit. So while writing the expression, again this is your, we have to apply Kirchhoff's current law. Right. When you apply Kirchhoff's current law, the current flowing through it, that is here to this node 1 I am having a source current I of t. So this I of t is equal to, again current flowing through this capacitor is represented as C1 into dV1 by dt, because this capacitor C1 is connected to V1. Right. And next one is plus, again current flowing through this resistor is given by the formula V by R. Here R1 is connected between V1 and V2, and now I am considering node 1. So I have to write it as, this is at node 1. So here I have to write it as V1 minus V2 by R1 plus, again current flowing through the inductor is represented as 1 by L1 into integral of, again this L1 is connected between V1 and V2. So here I am writing it as V1 minus V2 into dt. Right. That's it. This is our respective nodal equation for node 1. So next one is consider our node 2. So to this node 2, just again write down the expression. So here in this case, again this R1 and L1 is common for node 2 and node 1. As we are considering node 2, here I have to write it as, again there is no direct current source here. So 0 equal to V2 minus V1 divided by R1 plus again 1 by L1 integral of V2 minus V1 into dt, because here I am considering node 2. So I have to write it as V2 minus V1 respectively, plus the next one is C2. So here C2 into dv2 by dt plus next one is this R2, and this R2 is common for node 2 and node 3. So here I have to write it as V2 minus V3 divided by R2. Right. This is the respective nodal equation for your node 2. Again, this node 2 consists of 1, 2, 3, 4. 4 elements, and our expression also consists of 4 parts. 1, 2, 3 and 4. And finally at node 3. So when you consider node 3, again you are having 3 elements which are connected. So write down the expressions. No current source for this node 3, right? Because we are having only simply elements. So current source is 0, which is equal to V3 minus V2 divided by R2 plus plus C3 into dV3 by dt. Again for L3, 1 by L3 into integral of V3 into dt. So this is the respective expression for node 3, right? Here comes the end of the problem. Hope you all understand. If you have any doubt, let me know in the comment section. Thank you.